Okay, so we have to consider some gas laws to understand how ventilation and how gas exchange and all that works. So the first law is that gases move from high pressure zones to low pressure zones, which we kind of know that. Gases move from high pressure zones to low pressure zones. So high pressure to low pressure. Okay, pretty easy. All right, the second thing, or the second law, is a law named after a guy named Dalton. So Dalton's law. And if we're looking at a gas, so let's just say we have a gas in this space, in this box. And gas, like air, has different things in it. There are different gases here. So we'll call this one, we'll say the oxygen is that one. And we'll say this one here is CO2. And this one we'll say is nitrogen. So this gas is these three gases mixed together. So each one of these, because they each have their own properties, has what we call a partial pressure. And we denote that with a P. I guess I should. P. 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 So we have the partial pressure of oxygen, this part here, the partial pressure of CO2, those few there, and the partial pressure of nitrogen there. And when we add that together, you get the total pressure of the gas. So each one of these is a partial pressure. So that is what helps us understand, or that's how gas exchange works. Because the gases will move down their partial pressure gradients. So the gases will move down their partial pressure gradients. So just like a solute moves from a place of high concentration to a place of low concentration, that's diffusion, gases move the same way. They diffuse the same way from an area of a high pressure, so high partial pressure, to an area of a lower partial pressure. All right. Okay. So again, when you add these up, you get the total pressure of the gas. So if we measure gases or pressure in millimeters of mercury. So let's say the total is 100. Then these three would have to add up to that 100. So oxygen might be, 30. This one might be 40. And then this one would have to be 30. And that would equal to 100. So just the total gas in here, which is this, is the partial pressures added up. Okay, so the last law is called Boyle's law. And this law basically says that the volume and pressure of a gas is, or are, I guess it's R, inversely related. So what does that mean? So if we have the volume of the gas is high, then the pressure will be low. And if the volume of the gas is low, then the pressure is high. So this is important in ventilation. So if you're looking at this box here with this gas in it, remember that these particles are not staying still. They're moving. And they're moving around and they're knocking on the side of this box. So there's a volume, whatever this volume is, the more that's in there, or the larger the area that this is, then the less that these particles are going to hit the sides. So basically that's happening there. So if the box gets smaller, then the volume decreases and the pressure goes up, because if there's a smaller area, there's more gas in there, the same amount of gas, but smaller area, and it just means that those particles are going to bounce off the walls more. And if we make it bigger, the box bigger, then that 100 millimeters per mercury of gas is going to have less pressure, because it's going to bounce off less. Okay, so next we'll talk about then pulmonary ventilation, which utilizes Boyle's law.